Hello, so today we're looking at the distance from a point to a line in R2 or in 2 dimensions. Okay, well, let's look at what we're being asked. We're asked to determine the distance from point P, which is 4, -3, to each of the following lines. So we're given 3 different lines. Okay, so let's actually look at the formula or the expression to find the distance between a point and a line. So we have two situations, when we're in R2 or when we're in R3. So it looks like these questions in this section are in R2. So if we have a point P0 in R2, x0, y0, and a line ax plus by plus c equals 0 in R2, then the distance, let's use a color, the distance from that point P to that line, so we have our line and our point P0, that distance, perpendicular distance, is given by this expression here. It looks like you take the absolute value of ax0 plus by0 plus c and divide that by square root of a squared plus b squared. Now in R3, we have our diagram. We have our line L. We have our point P0. We also have a point P1 on the line. We have another point Q on the line. Of course, we have our direction vector M for our line in R3. In this situation, the distance, that perpendicular, is actually perpendicular distance, that's the shortest distance from a point to a line, is given by this following expression here. So in this case, d is the magnitude of the cross product between the direction vector and the vector p0, p1 over the magnitude of the direction vector of our line. Okay, so now let's go back to our questions. All right, so determine the distance from point P. So why don't we draw point P? Point P to each of to some line. And we're given 3 different lines. So it looks like if we go back to our formulas or expressions, looks like we're using this first one right here. All right, so let's take a look at it. Let's scroll back and let's use it. Okay, let's pick a color, purple. So, A. Okay, so our distance is our absolute value of our line evaluated at our point over the square root of the normal to our line, or rather the magnitude of the normal to our line. So in this case, 3 squared plus -4 squared. Okay, let's evaluate this. So we have 12 plus 12 plus 5 over square root of 9 plus 16. Yeah, this equals 29 over square root of 25, or 29 over 5. Good. All right, let's do the second one. B. Again, same expression, different lines. So 12 times 4 plus 5 times -3 minus 24 all over the square root of 144, that's 12 squared, plus 25, that's our 5 squared. Okay, so let's calculate this. Big numbers here. Sorry, 12 times 4 is 24. Whoops. So I've got the eraser on 24 minus 15 minus 24, the absolute value of that value. Then we have 144 plus 25. I think that's 169. That looks right. 9, yes. Okay, it's not so bad. Equals, or 24's cancel. Let's make this a little smaller so we can save a bit of space. Equals, in the numerator we have the absolute value of -15. In the denominator we have square root of 169 is 13. Actually have 15 over 13. Good. And we have one more. Okay, so in part C our line is 9x plus 27y equals 0. So our distance is absolute value of 9 times 4 oops, plus 27 times -3, okay, plus 0, good, over 9 squared plus 27 squared. We take the square root of all of that. Okay, so we got some larger numbers now. 9 times 4 is 36. 36 minus, I think 27 times 3 is 81, minus 81, all over, again, big numbers, 81 plus 27 squared, 729, take the square root of that sum. Okay, 36 minus 81. Okay, we have negative 45 in the numerator. The denominator, what do we have? 81 plus 729. Again, big numbers. Okay, all right. Okay, so we have 45 over 81, square root of 810. Now, I think we can factor out some things here. All right, so first off, we have a factor of 81 in the denominator. So it's actually 81 times 10. 45 is 4 times 9. Let's keep that in mind. Actually, what am I saying? It's 5 times 9. Square root of 81 is not 9. We have our 5 times 9, so we cancel out a factor of 9. And our result is 5, or our distance is 5 over square root of 10. So again, we can probably stop, depending on what kind of answer your teacher's looking for. We can stop here. But if you're asked to simplify, just keep going and look for ways to simplify and common factors. Good. All right, so number 2, find the distance between point P and the given line. Okay. Okay, so now this one's interesting. So let's go. So in this case, we're in R3. So let's go back up here now. I find. So if we go back to the title of this section, distance from a point to a line R2. So we just did that part, but we're also looking at distance from a point to a line in R3 as well. So I do find that interesting. And R3. So the next set of exercises are dealing with this second expression. So we're looking for the distance of a point to a line, but now in R3. So we're given a point. Now we have to find a point on our line. All right, so let's go back to our question. Let's draw this out. Let's pick a contrasting color. So we have a point P and we have a line. Like the line there. Okay. All right, so we need to find this distance. So we need to find a point on our line. So that's pretty easy. Okay. Need our direction vector. So in part A, our direction vector is 2, -1, 2. Our point P1 on our line is 1, 0, 0. Okay, the vector P0, P1 is given by, so our P0 is 0, -1, 0. So we can write that as 1, 0, 0 minus 0, -1, 0, 1, 1, 0. Okay, so to find our distance, we need the magnitude of the cross product of our direction vector with this vector P0, P1 all over the magnitude of our direction vector. So why don't we find this cross product M with P0, P1 and see where we end up. right, so let's take a moment. Stop this. Okay, so we're back. We want to find the cross product between our direction vector m and this vector p0, p1. So let's start with that. Let's scroll up a little. Actually, let's scroll over to the right so we have a bit more space. Looks like we're running out of space. So m cross p0, p1. All right, remember how to do that? We're going to make this box of numbers and plug in our first row is our unit vectors I, j, and k. Our second row is our vector m in this case. And our third row is this vector p0, p1. All right. Okay. So remember how we find this cross product. So I times, look at this box of numbers, 0 minus 2 minus j times 0 minus 2 again, plus k times, look at this first block of numbers, and we get 2 minus -1, which is 1. Okay, so now we have -2i plus 2j plus 3k. Good. So we actually need the magnitude of this vector. So how do we find the magnitude of this vector, or what is this vector? This vector in coordinates is -2, 2, 3. The magnitude is 4 plus 4 plus 9. And what does that equal? That equals the square root of 17. Good. All right, so now let's go back to our distance. Okay, so in the numerator, we have the square root of 17. In the denominator, we have the magnitude of m. So let's figure out what that is. It's the square root of 4 plus 1 plus 4. So we have the square root of 17 over square root of 9 equals square root of 17 over 3. So the distance from our point P in part A, 0, -1, 0, to this line in vector form is given by this expression d, the magnitude of the cross product of our direction vector, the vector p0, p1 over the magnitude of the vector m. And our final result is the square root of 17 over 3. Now it looks like we have one more exercise, part B. Let's do that over to the left-hand side here where we have a bit more space. Pick a different color. Again, same procedure. All right, so let's figure out what our point P is. Our point P a little smaller so we can see everything. Okay, looks good. So P equals, we'll call P0 equals 2, 1, 3. Our vector M is our direction vector is given by 0, 1, 0. Our point P1 on our line we can take as 2, 1, 0. So our vector P0, P1 is given by the following. Let's figure that out. So 0, 0, -3. Okay. All right, so now let's find this cross product. Okay, so M, our direction vector is 0, 1, 0. Our vector P0, P1 is 0, 0, -3. Okay. I, and this equals I times 1 times -3 is -3 minus 0 minus j is 0. Okay, so we got 0 times -3, 0 minus 0 times 0 plus k, and k is 0 to 0 minus 0. Okay. So our cross product is a vector negative 3i, or in coordinates negative 3, 0, 0. The magnitude of this vector, which is what we need, is just 3. What's the magnitude of m? Let's find that out. The magnitude of the vector 0, 1, 0, that equals 1. So therefore, our distance from the point P0 to our line is the magnitude of m cross P0, P1 over magnitude of m. It's 3 over 1 or 3. Good. All right, so that brings us to the end of our section. Just makes it a little larger. If you have any questions, feel free to send us an email at info@raisemymarks.com or give us a call day or evening, and we'll be happy to answer any questions you have. Thank you for watching. We look forward to seeing you again soon.